Hello everyone and welcome to this course on modern application development. So now I'm also going to start bringing in a few examples, right, and show you a little bit about what certain kinds of code could look like. What I have shown on the screen over here is in some sense the simplest possible web server, right? Not exactly the simplest possible but close. Okay, so let's try and understand what's happening over here. This has been written in shell script, okay, which means that all of these things, the while, true and so on, are things which you can actually type into a Linux or Unix shell and they would execute as commands, okay. And there are some specific parts of it which I will try and explain over here and then show you later as an example what exactly it does. So this initial part, the while, true, do, is something in shell script which basically says keep on repeating whatever is inside over here indefinitely until I use some other mechanism to kill this program, okay. And the done is just sort of closing out whatever is there corresponding to the while do. So what really matters is what is happening in these two lines internally, okay. And what is happening is it's sort of a two-stage process. You can see the symbol right at the end over here. This is called the pipe symbol. So what it says is do something with line number 1, okay, and pipe that information into line number 2, okay. Those of you who are not completely familiar or comfortable with Linux or Unix based systems, I would strongly recommend that you do try out and get some familiarity at least with the basics of scripting. And the reason being that even though you don't absolutely need it in order to write a web app, for example, it helps a lot to understand what is happening behind the scenes. For the most part, whatever is required for this course I will be explaining as we move along, but in case there are parts that are not very clear, you might have to look outside for further information about them. So now let's take these two lines and understand them individually, okay. The first line is fairly simple. All that it says is echo, and echo is a very simple Unix command. Echo minus e in this case just basically whatever is there within these quote symbols over here, right, the double quotes, it just prints it out, okay. Normally it would print it out onto the screen, but the way that Unix works is that it actually prints it out onto what's called the standard output, std out, okay. And the std out can be redirected using this pipe symbol so that instead of going onto a screen, it now goes into the second program, okay. So what exactly is the echo outputting? It is printing out some information over here, right. The first part of it is what you can see, http/1.1, okay. So remember, I am creating a server. This is the output of the server, which means this is the information that goes back to the client, right. And http/1.1 basically says this server is responding with an http 1.1 code. What is the code? 200 OK, right. So http code number 200, http defines something called status codes, right. 200 is one of the status codes, right. 301 is another one which indicates that a page has moved. Probably one of the ones that you are most familiar with is the 404, right, the 404 code, which basically says page not found, right. In fact, it's got to the point where it's almost become the subject of memes, right. So something's gone 404 basically means it's missing. But where did that come from? It's an HTTP status code. The server responds with 200 if it says everything is okay, 404 if something was not found. Now in this particular case, as you can see, this server is always going to say 200 OK, right, because I just have a while loop where all that it does is print out 200 OK. This \n is to leave two lines, blank lines. That's how the HTTP header and data are separated, okay. And what's the information that it gives out after all that? The date, okay. So the dollar and within parenthesis date is a way of telling the shell script to actually run this command date and take whatever information comes from there in place of that dollar parenthesis, okay. So this echo command, in other words, is going to print out the present date. but is it going to print it onto the screen? No, it's going to pipe it into this second command out here, right, which is nc. This is a command called netcat, okay, and netcat is going to listen on localhost, that is the local server, port number 1500, okay. So that's it, that's what this server is now doing. Essentially what it's saying is the nc-l localhost 1500 is the part that's actually implementing the server, okay. What that means is nc will cause the operating system to open a port and will listen, and anytime a request comes in on port number 1500, that will be fed to nc. What does nc do? It will just take whatever came from the echo and send it out to whoever asks it anything on port 1500. Okay, so the nc is not really doing anything very bright. It doesn't interpret the request. All that it sees is request came on port 1500, fine, respond with this, right. The point is this is sufficient to create a very trivial form of web server. Let's just see what this looks like in practice. So what I have done is I have connected to a Linux based machine, and what you can see is that this program that I just indicated before, right, the while true, do, the echo, pipe and nc and the done, right, I just put everything together on one line, right, just to show that you can create a web server in one line of code, right. What is this part out here right at the top, bin/bash? That's just something that we add at the beginning of shell scripts to indicate what should be the server that is to be used for this. Not strictly speaking necessary in this case, it's just a hint to the operating system so that it becomes a bit easier for the operating system to know and run this code, okay. So now if I take this and I actually run it, right, by typing bash, by the way, is the name given to what's called the born again shell, right. It's one of the shells. A shell is something that we use in order to interact with a Unix based system. So bash is the shell that we are using for this particular set of scripts, okay. So I have this small script. I know that what it's supposed to do is run a while loop, which is just going to go into an infinite loop, right, and wait for information. So when I run this, nothing happens, okay. And then when I think about it, that makes sense, because all that it's doing is it's basically doing a while true, echoing something, piping it through nc-l and waiting, okay. It doesn't really have anything else to do over here, right. So how do we check whether this is going to work or not? For that, now I know that this is actually working like a web server. Can I connect to it in some way and retrieve that information and see, okay, does this make sense, right, or is it behaving the way that I wanted? What I'm going to do is I'll open another shell for that, right, and what I have in this other shell over here is that I will use a command called curl, right. Curl is again a very useful command in general for people who are doing app development, and the reason is it allows you to create custom requests to a web server, right. It takes care of a lot of the background thing like sending the right kind of headers and so on, right. All of that information is taken care of by curl, so you can do it without really having to worry about the details of the HTTP protocol. Now in this case, what I know is that I can send a request, right. What kind of request? It should be an HTTP request. The :// is how I sort of separate out the protocol, the HTTP protocol, from the rest of the thing, that is the server and the path on the server. Everything put together is what's called the URL, the Uniform Resource Locator, right. In this case, the HTTP says that the server that I'm connecting to speaks the HTTP protocol. What that means is it expects HTTP requests and will give me a response which is a valid HTTP response, okay. Now go ahead and connect. Now which is the server? I know that it's on the same machine because all I did was open another shell over here. So I'm going to type in localhost. But one thing to keep in mind is, you remember what we saw earlier, this shell, this script is connecting on port number 1500, okay, not on the regular HTTP port. So let me put that information in there, right. I just say localhost : 1500. And now when I do this, can we think about what we expect to see? What was my server doing? It's just basically going to print out this information, okay, and then print the date, okay, which means that what I'm going to get back from the server will be all of this header information and the date, okay. But remember that curl is actually a full HTTP client, which means that it won't show you the header information, right. What it will show you is just the date, okay. If I go back over here, I now see that there was a get request, right, and this request over here, get/http/1.1, was what came from curl. It also said that it wanted to connect to the host localhost : 1500. It also specified what kind of user agent it is, gave some information about itself, and said what is it willing to accept, which is pretty much everything, okay. The response came as this piece of information, okay. If I run that with a verbose flag, that is a -v over here, I'll find that I get a bit more information, right, and we will look at this in a little bit more detail. So in other words, what you can see from this is that, and once we go back to the server, we can see that I got one more request, one more piece of information from curl, right? All of this, these 4 lines essentially came from curl, and all I did was respond with this, okay, which showed up as the date on the other end. Okay, so let's look at this in a little bit more detail. So in other words, what we have is the server itself just had these 4 commands, and all that it was doing was listening on a fixed port, right, 1500. Whenever the incoming request came, it ran some code, the echo, right, and the $date created a result actually on the fly. So in this sense, this is a fancy web server, it's doing something dynamic, right? But it has standard headers that are to be sent as part of the result, and the output can be either text or some other format, which is usually called a MIME format, right? MIME stands for, I think, multimedia internet mail extensions. It was defined for the purposes of sending email, right? But in email, you could have different kinds of attachments. So that's where MIME originally came into the picture, but it's been extensively used in different parts of the web since then. Okay. So as we saw over here, this is what a typical request looks like. This is what went from curl to the web server. This part, the get HTTP/1.1, is a standard thing, right? It has to be there. That is the actual request. The next 3 lines are actually optional, right? But in the case of HTTP 1.1, you at least need to specify this host, because HTTP 1.1 says that I could have multiple hosts running on the same machine. So I need to specify which one I'm interested in talking to. The user agent is optional, but usually useful, right? Most web servers need to see the user agent so that they can decide how to respond. If they see that it's a command line interface like this, they might just give a very trivial response. If they see that you're running Chrome, they may respond in a different way. If they see that you're running Firefox, a different response. Not always required or even a good idea, but possible. Most of them require this thing. And finally, there is accept ****. The **** is a way of indicating the MIME types, right, that the client is willing to accept. In this case, it's curl. All that is going to do is take whatever it gets and just dump it out onto the screen, right? Which is why it's saying ****. I'll accept anything, right? So this is what a request looks like. And this is pretty much what we did, right? We just ran the curl -v http //localhost:150. This is the full response, okay? And let's analyze it in a little bit more detail because it helps to understand the sort of back and forth, the protocol between the client and the web server. So what we have is this, everything starting with a star over here, right? These 3 lines as well as this line down here are just debug information from curl. They are not part of the protocol, right? It is not sent from the client to the server or back. It is just printed out for you as debugging information. So as you can see, what it says is it's trying : This : by the way is an IP address, but unlike the format that I mentioned earlier, which is just 4 numbers separated by dots, this is actually something called an IPv6, the version 6 address. For now, you can just ignore it. : means localhost, means your own machine. This TCP no delay set is again some part of the TCP tuning settings that are done over there, right? I believe it controls how fast the connection will be set up and how quickly it will try to ramp up the speed at which it is trying to download information. But for now, you can just ignore it. So the good news is the 3rd line, which says it connected to localhost, right? If there was no server running on localhost, it would have said either access denied or server did not respond or something like that. Okay, but in this case, it's good. It connected to localhost port 1500. Okay, and after that, this last part, ignore it. We don't really need to worry too much about what is this information over here. It's just pretty much curl saying, okay, I reached the end. I didn't get any further information. What is useful is to instead look at what was sent from curl to the server, right? And it's these 5 lines, right? Look at this last greater than over here. This blank line is important, right? Unless you give the blank line over there, the server doesn't know that you are done. Okay, so curl basically sends out a get /HTTP/1.1. So get is the request. It's the type of request. It's basically saying I want to get some information from you. What information? /. / is a way of indicating that I just want information, your basic core information, the root information, right? I'm not giving you any further details on what I want. Just give me the whatever is your starting point, so to say. And it's also mentioning that the protocol it's using is HTTP/1.1. Okay, there are many different variants of this. There is HTTP/1.0, which is almost not used these days. 1.1 is still the predominant one, the most commonly used version of the protocol. HTTP 2.0 has nothing whatsoever to do with Web 2.0, right? HTTP 2.0 is a different variant of the protocol that allows certain other things. So for example, it allows pipeline connections and so on. It is used in quite a few places these days, especially for things which require continuous connectivity and downloading large amounts of data. And in fact, HTTP 3 is also in the works. It is not yet widely deployed, but it exists, right? But for all practical purposes, the most dominant version of the protocol even today is HTTP 1.1. All that it matters is, you're giving this information about the host, the user agent, and what you're willing to accept. And then you give a blank line to say, okay, I'm done. Nothing more from my side. I'm waiting for your response. Immediately, the response comes back, right, from the server. The first thing it says is HTTP 1.1 200 OK. Remember where this came from? This is exactly from the shell script, the echo part, right? HTTP/1.1 200 OK. That was just hard coded into our server. It will always respond with HTTP/1.1 200 OK because that's all that there is in the code, right? Even if you sort of make a mistake in what you type into the curl, as long as it connects on this port, this is the response you will get. Okay, and then there were 2 \n. Remember, \n. One is to say go to next line. The next is leave one more blank line after that. Okay, Just like in the case of the incoming requests, those two blank lines, or rather the one blank line over there, indicates end of headers, start of information, and the information itself corresponds to the date. Okay, so it basically just responds with the date that it has over here, right? So ultimately that's what is happening, right? I mean, all that the client is doing is sending a request in pretty much text format, right? So you can actually read the request and make sense of what is being sent. The server also sends back its headers in text format, followed by the actual data that it wants to respond with. Okay, so this, in other words, is the full sort of back and forth in a simple web communication. Hello everyone, and welcome to this course on modern application development. Okay, so now let's sort of try and understand a we have seen an example of what a web communication looks like. Let's try and understand a little bit more about what is a protocol and some examples in the context of HTTP. Right? So, like I said, a protocol basically means that both sides of some communication agree on how to talk to each other. Right? So, for example, when we walk into a room, the usual protocol that we are expected to follow is that we smile at whoever we see, we greet them, exchange names, maybe, right? Possibly shake hands. Those are all part of a protocol that we follow. Okay, that's between human beings. In the same way, right? You also have protocols for how computers are expected to communicate with each other. Right? Now, if I connect to another computer on port 1500, I need to know what kind of information it is expecting and what it is likely to respond with. Okay, so if I go there and just start typing text, the other side is most likely not going to understand what I'm talking about. Okay, which is why we need to sort of have a protocol which specifies the nature of my request, what kind of responses I'm expecting to see, what I am as a client, right, and what kind of responses I can actually deal with, right? So the server now has more information about me and can respond accordingly. So the client is also, asking the server for something. The server is then responding based on what the client accepted. These two things, how do they communicate with each other, is what constitutes the protocol. Now, the hypertext transfer protocol is a very specific version of a type of protocol, right? It is primarily text based. What I mean by that is, as you saw already, most of the actual information, the header information, is encoded as text. So you can actually read the information, right? So you can see a get, and you can actually see it. It's not that it's been interpreted as get or something like that. It's not a number which got interpreted as get. It actually has get in the text, which means that if you happen to see the back and forth, you look at the bytes on the wire as they are passing by, you can see that this is actually a get request going to the server. It also, the headers can be used to convey a lot of extra information, what kind of languages you're willing to accept, what kind of encodings, what kind of response types you expect to see, and so on. Similarly, the response headers will also be in text and convey information about the message itself, right? Also about whether this information can be cached and used later, and most importantly, status codes. We already saw the 200 OK, and like I said, the 404 not found. There are many other codes that are defined as part of the HTTP specification. These are obviously the most common ones, right? 200 OK is what you hope to see most of the time. 404 happens once in a while. 500 is something you really don't want to see because it means server error, right? Something crashed, the server crashed, or something happened over there, right? There are similar ones. I mean, there are a bunch of like 300 errors which are sort of harmless. They sort of are just warnings more than errors, and various different kinds of codes that are defined as part of the HTTP specification. So what are these use cases, right? As we saw already with the simple web server, get is used for the most simple requests. It just requests information, gets back data. So most of the time, things like search queries and so on, when you are like connecting to Google and doing a search, most of the time what you would probably be doing would be a get. Right? Post can be used for more complex data. Let's say you have a form with multiple fields in it, right? There's a name, an address, various other things. You can't encode all of that into a get. At least you can't do it easily, right? Post is a much better way of doing this. It can accept large blocks of text. So for example, even in Gmail, when you are typing in an email and hitting send, that entire block of information is finally being posted to the web server, which accepts it, puts it together, constructs an email out of it, and sends it, right? There are many other requests as well, right? Some of them called put, something called delete. There are a few other variants which are much less common but are used quite extensively, especially in Web 2.0, in the dynamic web, right? And many sort of APIs, application programming interfaces, including the so-called REST interface and CRUD interfaces to databases that we will look at later, are sort of built around these kind of these parts of the protocol. So just to give a few more examples, what I'm going to do now is run something a slightly more complex web server, right? So this is again a one-liner. I'm just running the Python interpreter, right? And the -m basically says to execute something, right? And what is that something? It basically says take the module HTTP and run the function server from inside the HTTP module. Okay, so in some sense this is a one-line web server, right? If I go back to my shell script, I can basically kill this and clear this as well. And if I now run this command python -m http dot server, it now gives me a little bit more information than my shell script, right? It actually tells me serving HTTP on 0000. So this is the local IP address. Well, more importantly, this actually says on any IP address that this machine is connected to. It also tells me that it is running on port 8000. I didn't specify port 8000, that just happens to be the default used by the Python HTTP server module, right? And so now what happens if I once again run curl -v http //localhost 8000. I can see that it actually gives me a lot more information out here, okay? And this is actually surprising. It's giving me information which is much more than what I expected, because I don't really have anything over there, right? But if you look closely at it, you'll realize that what it has done is it has automatically created a directory listing. Okay, it is showing me the list of files that I have. Okay, so rather than worrying about this, what I'm going to do is take another couple of examples of requests that would go out when I run this Python web server, and if I use curl in order to connect to it, right? If I do something like get / and let's say I did not have this particular thing, right? I did not have a directory listing. Normally what it would do is take a file called called index.html. Let's in fact create a file like that, right? So you can see that index.html, I created it such that it just has one line saying hello, right? Even though I call it a .html file, it doesn't have any tags or anything that you would normally expect to see in an HTML file. Now what would happen if I run the same thing again? I would find that this basically responds by giving me back whatever I had in index.html. Okay, this is actually part of something called convention. It's not really part of the HTTP protocol, right? This is more of a convention which says that in a given directory, if I find a file called index.html and I just get a request for the directory, right? Get / or get the directory name, go pick up whatever is in index.html and send that back to the requester. Okay, so what we can see, right? I'm going back over here. Let's look at it in a little bit more detail. Like I said, the first 3 lines essentially, anything with a star is just debugging information. These 5 lines correspond to what was sent by curl, exactly the same as previously. The only difference being that now it is connecting to port 8000 because I told it that the server is running on port 8000. This star again basically is just extra information, right? I mean, this is debugging information from curl. But the response from the Python web server is this bunch of lines. Okay. Notice one thing, it's using HTTP 1.0, not 1.1, unlike the previous one that we had, right? Makes life even simpler because 1.0 is actually a very simple version of the protocol. 1.1, even though I had 1.1 over there, actually requires a little bit more information for it to work. It also gives back information about itself. It says that it's a simple HTTP server with Python 3.9.2. That's the version of Python running over here. It gives the date, but this is part of the header. It's not something to be displayed, right? And then comes the MIME type of the result, right? It basically gives the content type and it says it is text/HTML, right? The original one-line web server that I had did not have any of this information, but ideally it should, right? Because this is what allows the browser to display the information correctly. The content type and content length are actually important in pieces of information to have. In this case, this text/HTML is useful. It basically says treat whatever you are getting now as an HTML file, which means basically display it. If it said application/PDF, then what would happen is it would download and probably open a previewer or something to display it. Right? Content length is 31 bytes. Well, that's because I had some information out here, which was a total of around 31 bytes or so. Right? It also gives a last modified, basically telling when was the file that it's sending to, when was it last modified. Why is this information useful? Because from the client's point of view, it might find that if you're trying to reload a page, but the server says it was last modified 1 week ago, then the client might decide, okay, I don't need to do anything. I don't need to change what I'm drawing on the page because nothing has changed. Okay. So finally, we have the actual text coming back from the index.html file. Right. So this is sort of the transaction that goes back and forth when you do a get / right? Just curl http localhost 8000. Now remember that I had this file serve.sh sitting over there, right? And if I tried a request to that get /serve.sh, what do I expect will be the response? A similar set of headers from here, except that now the content type it now says is application/xsh. That's just a MIME type corresponding to a shell script. Okay, and what's the actual data that comes back? The script itself. Okay, so in other words, any file that you had, the server, if it is written appropriately, should be able to find out the MIME type, the content type, send that back to the client, and also send the data as required. Hello everyone, and welcome to this course on modern application development. So now with all of this in mind, now we know how a web server works, right? There are many issues that come up in the context of performance, right? And what we mean by that is how fast can a site operate? How quickly can it respond to requests? What are things that limit the performance? Okay, so let's try and look at some basic observations. These are just sort of back of the envelope calculations, so to say, that I'm going to show over here. But they are important to keep in mind when you are developing an app. Probably not in the beginning stages when you're just sort of starting out with an app. Maybe you don't need to worry too much about these details. But at some point, hopefully, whatever app you are creating is something that you want to scale, right? You want more people to use it. At that point, there are a number of issues that come into the picture that you need to keep in mind. It's worth sort of at least understanding those in the context of the server and let the response for a given name. Now, so as we know, the speed of light in vacuum is about 3 into 10 power 8 meters. So nanoseconds to come, that mean it has to, in other words, the information expires. The bottom line is it's around like and handy, probably not even a single data center. Now going to look at markup and what it means and how it is used in order to control how something gets displayed on a screen. Now this is a very primary or a main part of what is called the user interface, the part that faces the user and how we interact with the computer in the first place, right? So markup is something that is used in order to change the way something is shown to the user and ultimately deals with the aesthetics or the sense of beauty or the sense of how nice something looks. And obviously, as you would all be familiar by now, the better that a site looks, there are some sort of indefinable ways in which you can clearly say that one site looks better than another, right? In some cases it is obvious, in other cases it is less obvious, but there is a concept of aesthetics that finally determines how we interact with a website. So markup plays a very important role in that because ultimately that is how the developer, the person who is developing the website, can make changes to the website in such a way that the way that it gets displayed to the user changes. So let's try and understand what it is. So we are going to look at a few things. First of all, how do we represent information inside a computer? There is also a distinction between the so-called raw data versus the semantics. What does it mean? We will also try and understand the distinction between logical structure of a document versus the styling, how it is presented to you. And finally, we will look at HTML5 and CSS, but only at a very high level, primarily because those are the technologies that we will be using as part of this course, because as far as the web is concerned, those are the primary underlying presentation technologies, the parts that determine how a page looks. Okay, so first things first, what do we mean by information representation? Okay, as you're all familiar, computers work only with bits because ultimately they are digital logic systems, which means that you are essentially everything inside the computer, any not just computation but even information is stored in the form of bits, either a 0 or a 1. This works out nicely because from the electrical standpoint, you have either hello everyone and welcome to this course on modern application development. Okay, so now with all of that behind us, we are now going to look a little bit more into detail on HTML and its variants. Okay, what is HTML? Hypertext markup language. So HTML in some form, as not quite the form that we know it now, was first used by Tim Berners-Lee in the original web at CERN, right, the European Center for Nuclear Research, roughly in 1989. I believe that HTML was in development by him even before that. Now, it's not that it came out of nowhere. HTML, the idea of markup languages already existed, and in fact, there was something called the Standard Generalized Markup Language (SGML), right, which was meant as a way for creating other markup languages which were more sort of domain specific. Okay. Now, SGML has a number of very strict restrictions on the structure, on the syntax, the validity, and so on. HTML, on the other hand, was meant primarily for browsers. And right from the beginning, one of the, I think, conscious decisions taken over there, which has had a very interesting impact further down the line, is that since it was meant for browser interpretation, the approach that the original inventors took was that, look, it has to be forgiving of mistakes, right? Because after all, a person typing an HTML document is entirely likely to leave out some tag here or there, right? And let's say if I try loading that into a browser, and the only thing that I keep seeing are error messages, I'm not going to really use this, okay? On the other hand, most of the time, if I know that a person started, let's say, a title or something over here, and then they jump to a new paragraph, I know that the title has ended before I started the new paragraph. So why not just let the browser be forgiving of these kind of mistakes and do a best effort interpretation? Okay. So HTML was a markup language along the lines of things like SGML, which already existed at that time. It had a few things that were very specific to how you would mark up something for display on a screen, right? And basically for annotating hypertext, so to say. And given the fact, the context in which it was being used, the fact that it was meant for some kind of interaction between different people, right? They decided that the browsers also need to be sort of as forgiving as possible and do a best effort to display what can be displayed, right? This is an example of an HTML document, right? Sort of pretty much the simplest document that you can think of. This first line that you can see over here, I mean, this is a modern HTML document, which looks very similar to what HTML would have looked like 30 years ago, right? It's pretty much the same. But the point is, this line over here, doc type HTML, nowadays is considered more or less a requirement. You pretty much standardize and say, look, if you don't have that, it's not really valid HTML. In previous days, there were different variants of this. It wouldn't quite be this doc type HTML. It would be some other, they had things called DTD, document type definitions, and so on, which were trying to sort of stick with SGML, but were neither here nor there. Now, what we have is, in some sense, a simplified version. More important is the structure of the document itself, right? What it says is, look, this HTML pairs up with this /HTML at the bottom, right? Everything in between is your main document. Now, within that document, you have a body which starts here and ends with the /body. Okay. So what you can see is that every one of these so-called tags, right, has some name. In this case, body. In this case, HTML. And how is a tag specified? By putting these angle brackets, right? The less than and greater than signs around it. No spaces, nothing else around this. Just the tag immediately surrounded by these two angle brackets. Now, this body and /body is a structural element. It says that everything within this is the main body of the text. Within that, I have h1 and /h1. h1 is a first level heading, okay, which means that it usually would be in larger font size, etc. But how you display it is up to you. Similarly, you have another structural element called a paragraph. Okay, so now you can see where HTML is going, right? It's basically trying to sort of take the overall text and add these tags around it. The main text that you have is just this: my first heading, my first paragraph. You could have just written these 2 lines and you're done. Everything else around here is markup, right? Which is doing 2 things. One is it's telling other readers or even machines that look at this document how to interpret what is in different parts of it, and also it is specifying that there is semantic content, right? Meaning to this. This is a heading, this is a paragraph. Therefore, display them appropriately. So we always have paired tags, like the location. All of these things are usually case insensitive. That's generally not considered good style simply because it makes it harder to read, but there's nothing preventing you from doing it. Can you nest these tags? Sure. So for example, if I do something like this, right? EM is used for emphasis. Okay, this is a logical tag because emphasis, actually speaking, does not really tell you how it is to be displayed. If I say emphasis, does it mean that I should make it blink, or should I make it like in a bright neon color, right? What is usually done is to put it in italics, right? Use an italic font. What about strong? Strong indicates that whatever comes over here should be somehow, it should stand out, right? Once again, what is usually used is to make it bold font. But people sometimes confuse it and think that just by indicating strong it means bold font. It does not. Strong just means that strong is a logical markup, whereas bold font is a physical markup. Okay. In this case, since usually strong stands for bold and EM stands for italic, what will happen is the actual text which is between these tags will get displayed something like this. Why like this? First, it will apply the strong, which makes it bold, and then on top of that, it will apply EM, which will make it italic, and the result will be both bold and italic. Now, automatically, you might also realize that this means that you can have invalid combinations of tags, right? Supposing I write it like this: I start with EM, say strong, then give the word to be written, close the EM tag, and then close the strong tag. There's actually a mismatch because this EM goes with this, and the strong goes with this. They are not nested properly, right? Since strong was the innermost tag, it should also have been the first one to be closed before I went and closed the other one. In other words, as far as the document standard is concerned, the order in which you do these things does matter. Okay. Now, like I said, most browsers are quite forgiving. So if you do write markup like this, there's a good chance it will go through. At some point, it will indicate there was invalid HTML over here, but it will still try and understand what you wanted to do and display something which it thinks makes sense. Okay. What happens if you don't close one of the tags, right? You don't close the strong tag. You straight away go and close the EM tag. Is this valid? Technically, no. Once again, what will the browser do? Most likely try and make a best effort and realize that since you have closed the outer tag, the inner one must also have been closed. What about outright, typos or spelling mistakes that we have over here? Yes, this will most likely result in something which even the browser doesn't know what to do with. Because something like this, it doesn't even know whether it's a starting tag or an ending tag or what it corresponds to, right? It might indicate an error, but it's unlikely to display it on the main page. It'll probably just not format this the way that you expect. So, like I said, there's a difference between the presentation and the semantics. Both strong and B will result in exactly the same output. Which one is correct? Which one is better, right? It's not an easy question to answer. Which one is correct? Both may be correct. It's not very clear what you wanted to do. Did you just want something to be in bold font? If so, both of them are okay. But strong is actually telling you something more than that. It's trying to convey that to the reader that you want to emphasize this in some way. That's why you have put it in strong. Whereas B is simply saying, okay, put it in bold font. It's up to the reader to decide whether it's important or not. Okay. So B, in other words, is just doing presentation without worrying about the meaning. Whereas over here, you are concerned with meaning. So when you do use tags in order to indicate functionality, be aware of that. You should, as far as possible, try and use them in a context where the semantics, the meaning makes sense. Ultimately, that is the more long-lasting and the more important aspect of markup. Some rough timelines on the evolution of HTML, right? Like I said, the original HTML-based HTML started from the late 80s, right? Basically around 1990 or so. The first sort of formal definition, once the popularity of the web started taking off, HTML2 was defined in 1995. HTML3 as well as 4 were actually defined in 1997, right? And then for quite a long time, it was pretty much just HTML4 that continued, except that after a while, people sort of started switching over to something called XHTML, right? Now, what is the XHTML? This was based on the thing that, there was HTML by its nature and the way that it was constructed, right, is actually a very strict set of specifications. Whereas XML is something called the extensible markup language. It was meant to sort of reduce a lot of the difficulties associated with the use of HTML, make it easier to define new types of tags, right? Variations on tags, encapsulate different kinds of data, while at the same time being simpler to use than HTML. Right? And this is something that you very often come across in computer science, right? The original definitions are done by people who have put in a lot of thought. So it's not that HTML was unnecessarily complicated for the sake of being complicated, right? It had all that structure because of all the mathematical underpinnings, how it should be parsed, how it should be interpreted, what kind of tree structure should it have, right? A lot of thought went into that process, and that is why the entire HTML definitions were made in a certain way. But that also did make them difficult to sort of modify and understand easily. XML sort of took several learnings over the years, right? It was like more than 10 years of HTML use that came into play, and XML sort of tried to relax many of those problems or make it a little bit easier to use and understand. Based on XML, right? Once again, XML has very specific kind of meanings and interpretations. XHTML said, okay, now we'll once again look at it in the context of the browser, right? What kind of problems can be forgiven, what kind cannot, what should be expected of the HTML, right? But at the same time, bring the X factor into play and allow you to have slightly different representations of things. That remained for quite a while, right? Almost till the mid 2010s. And finally, now what we have is the dominant form is what's called HTML5. Right? This was sort of in development since around 2008 or so. It formally became a W3C recommendation in 2014, and nowadays it's pretty much the standard everywhere, right? And part of the reason why HTML5 really took off was in between, right? Before the rise of HTML5, but after HTML4 and so on, there were a lot of websites that used so-called Flash animations, right? So Flash was a technology from Adobe, which allowed you to do dynamic animations on websites. those websites, they had some nice features, they looked quite cool, they also allowed you to do more fancy interactions than possible just with HTML, but it was not really standardized properly. You needed a separate plugin, it was not part of the document standard, right? So it ended up being sort of heavy and not standardized. It would work on Windows machines, not well on Linux. It wouldn't work on the same way on different variants of browsers on the same machine, right? HTML5 attempted to sort of say, okay, let's address those issues and bring in some standards for how things can be done. And since about 2014, it's pretty much the dominant standard seen on the web. So what it does is that it also introduced a couple of logical elements, right? Things like block elements. So you'll come across this div, which is a very common element that you're going to see when you write HTML documents. It essentially means this is a block, something like a paragraph, right? You could have inline elements, right, which just are a span. So it basically spans across a few characters and say this is how this should be interpreted or displayed. Now, you could again abuse this in the previous manner, right? I mean, what we said about the difference between bold and strong, and just say, okay, this span of text has this characteristic, right? This font size, this, and so on. Ideally, you shouldn't, but it might happen. You could do something of that sort, right? It allows you to have fine-grained control over what happens where. But to a large extent, always what we are looking for when we have any kind of document like this is how do we specify logical structure rather than exact presentation. One additional aspect as far as that is concerned was the introduction of elements like nav, so the navigation bar, the footer, and so on, right? Now, these things are especially important in the context of accessible websites. What we mean by accessible is, let's say a person is visually impaired and cannot read everything that's on the screen, right? Is there still a way they can interact with this website? And there are screen readers, things that will take the text that is on the screen and read it out to you. Now, if this text is just one big blob of text, it becomes very difficult for a screen reader to work properly. But if you have used nav tags and footers and divs and spans properly, the screen reader can actually do a very good job of finding out which is the important part. Let's say you have one div which says main content, right? You can directly focus on that. Or there's another div that says abstract. That can be read out first, right? The nav can straight away tell which is the next link, which is the upper link, right? Any related links and so on. So that's where the logical markup becomes more important. HTML5 also introduced some new tags like audio and video in order to interact with media. Basically, you can directly embed an audio segment or a video, in an MP3 or an MP4 file directly into a web page, and it will play automatically. So it defines how the browser should respond when it sees those tags and so on. Certain other tags which are mainly only for presentation, something like center. There used to be a tag called center which would explicitly allow you to center a certain thing on the page. But think about it, right? I mean, going by our original definitions, that's direct physical presentation. It's not logical markup. Similarly, there was a font tag which would allow you to change the font that was used in a part of the text. Once again, they said, look, take this out of the HTML standard. There are other ways by which we can do this. Okay. So HTML, now that we have defined what an HTML document looks like, what the tags are, and so on, it also defines something called a document object model, right? So like we said, this is a HTML document. I've left out the doc type in the beginning, but it has this HTML and /HTML. Within that, it has two substructures. There is a heading and a body. Inside the header, there is a title. Inside the body, there is a first level heading and a link. Okay, all of this essentially corresponds to a single HTML document. Now, this is the document as we see it before it is actually displayed. The first thing that the browser needs to do is to parse this. That is to say, take out all of these tags and say the tags are actually telling me something about structure, about how the entire thing is to be interpreted. And that is where the document object model comes into the picture, right? What it says is each of these tags this entire structure can be interpreted as a tree like this. You have the top level document. Inside the document, your root element is this HTML, okay, which basically corresponds to everything which is inside the document. Inside HTML, I have head and I have body. I have an element head and I have another element body. Inside head, I have a title. And inside title, I have the text of the title. Similarly, inside body, I have a heading h1. And inside the h1, I have the text of that heading. I also have a link, that is a tag. It has an attribute, right? This is not part of the text, it's an attribute, it's an href, right? And it also has the actual link itself, this link text, which is available over here. Okay, so this HTML, the first thing that the browser does when it sees it is to try and parse it or interpret it as a tree structure like this. Why is this useful? Because ultimately you need to understand this document object model in the context of web apps, because you might have a way by which you can directly manipulate parts of the DOM, right? So there might be something where in a programmatic fashion you can go and directly change this h1 element which is inside body, or you could set the style corresponding to body h1 and say, okay, this is what this heading should get displayed as. So although it's not very important for us right at the beginning, understanding the DOM is important in terms of how we would modify the structure of a page or how it gets displayed. So it's a tree structure representing the logical layout of the document. What that means is the direct manipulation of this tree is now possible, right? Because computer scientists for a long time have a number of algorithms that operate on trees. It means that we know how to sort of move trees around, restructure, change the parent element of a given element, change the contents of one, go down a tree all the way and change all the elements inside it in a certain fashion. All of that can be done nicely using algorithms that are already known. Okay, so the moment you have this kind of a nice structure to the document, all those things get opened up. Now, in addition to that, a number of APIs are also defined on the DOM, right, the document object model. One of them is the so-called canvas, which basically allows for drawing arbitrary things on the screen. There is an offline API which actually tells you that certain websites, right, you might have come across sites that say, okay, click here to install it as an app, right? What that means is that the HTML corresponding to the site gets stored on a local machine, and the next time you access it, it will run even if you are not connected to the internet. Right? There are now APIs for web storage, which basically allow you to store certain information on your local machine, which means that it can become persistent. The next time that you go back to the site, it may say, remember where you left off, and be able to work with that. There are sort of utility APIs like drag and drop, which basically allow you to drag a file from your operating system folders and drop it into a certain location, right? So in other words, it brings this whole drag and drop that people are already used to on the desktop into the web browser. Okay. So all of those are defined as APIs, application programming interfaces, which the browser sort of standardizes and says, okay, if you use these APIs, you'll be able to get this kind of functionality. Now, in most of the cases, when we talk about manipulating the DOM, we use JavaScript. Okay? That's not something that we are going to be getting into in any level of detail now or in the near future, but it's something to keep in mind if you're interested in advanced development of applications. And the other thing is basically styling, right? How do I also control the representation of different aspects of the DOM? That is where CSS comes into the picture. Okay? And what is CSS is something that we do need to understand in a little bit more detail. Hello everyone, and welcome to this course on modern application development. Okay, so this brings us to styling. Okay, and what we are trying to understand over here is what do we mean by styling, right? What is the difference between markup and styling? What is markup? What is a style? What are these themes that you may have come across in different contexts? And finally, what is the role of CSS in all of this? Okay. So to illustrate the distinction between markup and style, let's take an example like this, right? I have marked up this word hello as a H1 title, a heading. Now, it could get displayed in any number of ways. These are some possibilities, I'm sure. Right? One of them is just to say, okay, use this font, size 24, bold. Okay? So this is, yeah, in the sort of matches with what you might expect to see as a H1 heading. This is another variant. How is it different from the above? It basically uses a different font. Right? Even larger font size, still in bold. Okay? And this third one over here is something that you hopefully don't see, right? Because it looks very scary. But is also a different way by which I could display the H1 heading. Right? I use a different font. The font is fine. The size is also okay. It's bold, but I've also added italic to it. The font color in this case is green, and the background is red. Right? Now, this would probably be a case where something got added. No, it's not really going to be very nice. Okay? Style. Okay? So, this separation of the styling from the markup is what allows us to create what are usually referred to as themes. Right? So, you're probably seeing themes in different places. So, in your operating system, you can choose different themes. There's a light theme, a dark theme. All of those are going with the same underlying concept. There is some logical meaning to all the things that are on your phone or your desktop or whatever it is. And there is a physical representation which is chosen separately. Right? And the concept that was brought in somewhere along the line was that why not use something called a style sheet, right? Which contains just presentation information. So, how does a style sheet work? It basically has, let's say, descriptions of different tags and says, okay, this is how each of these tags needs to get represented or displayed on screen. And that is where cascading style sheets or CSS came into the picture, right? By cascading, basically what it said was you would have multiple style sheets, each of which might have some overlap with the other. So, one of them might display what the next one should look like. The next one may also have something on top of it, right? Which basically says that you have multiple such definitions, and the latest one, or the last one that you have over there is the one that's going to take precedence. Okay? So, cascading style sheet was basically brought in just in order to separate out the styling from the markup, right? Let's take an example, try and understand this in a little bit of context. So what I have over here, these are some screenshots, okay, of something that's, this part of it on the right side is something called the developer interface, right, developer view that is usually provided by most browsers, and is something that this developer view has essentially shown us something, the body which has a heading and this link text, okay. This on the left hand side is how this whole thing got displayed, right, the heading basically went into the top left hand corner, but it also automatically becomes bold and a larger font size. Similarly, because this was defined as a link, it has some extra link text, right, which comes up in blue and underline, and nowadays we have pretty much come to recognize that if it looks like this, it's not probably a link that you can click. Remember, this is also just a convention. Right? This whole business of links being blue and underlined is something that came up from quite some time back. Okay, so what we have over here is what we can see is there's a heading, there's a link text. Now, if we skip forward, we can see that this also represents the link body. And if I go and click on the part which shows heading, it sort of pinpoints around that. Right? It shows me exactly what is the display portion corresponding to the heading. And if I look down here, it actually shows me all the styles corresponding to that. You'll notice that I don't really have any styles mentioned in my HTML file. So these are what are usually called the default styles that are built into the browser. Right? What it says is use a block display type, that is to say put the heading in a block on its own. Right? So that whatever text comes after that will come on the next line. Font size 2M usually means twice as whatever font was chosen. Other in this case WebKit link. What is WebKit link? It looks like a pointer in this case, which means that if I hover over that, then this is also display. Hello everyone, and welcome to the app. Right? So everything which comes after this H1 over here are attributes